Questions about your homework first. All right, guys, if y'all will put your laptops away, I know I'm behind getting started, but if y'all will tuck all that away, get out your homework. No, I bring mine with me because we don't have anything. Okay, can you give me the equation? You didn't have to do that one. You didn't have to do that one. I don't have any spares. That's why
I couldn't get one this weekend, so like, can I like not have a zero if I couldn't do it?
Let me show you the time plane. Did we do quadratic? We have not done quadratic form. This one is not on your sheet, but I'm gonna start with this one. So, I would advise you not to use this as your notes, but to do your notes in your notebook. I see most of you doing that anyway. But at the top there, thank you. At the top, the new patterns that we're talking. Oh, y'all didn't get them on the middle right? Okay. There are some places to fill in. If that's not enough, there are some more coming around this way, I think. To fill in these types, but we'll get to that in just a minute. Let's first talk about factoring polynomials. Now, we have done factoring quadratics until we were blue in the face, right? But, right, right. Okay, but now we're going to talk about factoring polynomials, which just takes it to a whole new level. That's all we're doing, okay? So a lot of the same techniques. Remember, how did we factor quadratics? GCF. We broke it up, we slashed it, we factored the GCF out of those pieces. Everybody remembers that? Okay, so a lot of those same techniques will be used here, but then I'm going to teach you some special patterns. And we did talk about some special patterns with quadratics. Do you remember what they were? Difference of squares was one of them. It's also a polynomial special pattern. What was the other one? Perfect square trinomial. So we're going to talk about several patterns with polynomials as well. First thing I want to, what? That's when you're solving. Yeah. All right. First type is what we call quadratic form. My computer is just laggy today. You have to be able to recognize quadratic form. Now be very careful because as I factor polynomials, remember these are bigger degrees than just 2, right? So I might have an x to the 10th or an x to the 15th or whatever it is. But what is that on top of that speaker back there? There's something on top of that intercom box back there. Yeah, I'm looking at it. It looks like something foul. What is that? All right. Here's quadratic form. There are three. What is that? What is that? What is that? There are 3 terms. Okay? Of those 3 terms, here's what has to happen. The last term has to be a constant. The signs do not matter. The degree has to be even. Even degree. The middle term exponent is half of whatever the degree is, okay? This clues me in that it's what we call quadratic form. And anything in quadratic form, I factor just like a quadratic. Which is when we did what we called grouping. Let me show you what I'm talking about. Let's make that a 9 in the middle. There we go. I'm just trying to think of one that'll factor good for us. All right, so if I'm asked to factor this, the first step in factoring is always looking for a GCF, right? All right, there is no GCF here, all right? So the next thing I want to think is there another way? Is it a special pattern, or is there some way that I can factor it that I can recognize? And here, the first thing that clues me in is there's 3 terms. So I'm going to try to group it if I can. The only way I can group it is if it's a quadratic or it's in quadratic form, okay? So look through. I've got 3 terms. That's my first check. The degree even? Yeah, the degree is even, right? Is the last term a constant? Yep. Is the middle term half the degree? Yes. So this can factor as quadratic form. So I'm going to do it just like I factored all the other quadratics. I want to multiply the first and the last together, and that gives me what? 10x to the 4th. What multiplies to 10x to the 4th but adds to negative 9x squared? Why does it keep doing that? All right, try it now. I changed that last line. What multiplies to negative 10x to the 4th, but adds to negative 9x squared? All right, remember, it's got to add. If I'm adding up to something, then they have to be like terms, right? So negative 10x squared and positive x squared. Together, that would add to negative 9, but it would multiply to negative 10. Yes? X to the 4th. Okay. So I've got 2x to the 4th minus 10x squared plus x squared minus 5. This is not new. The new part about this is because this is not a quadratic. It's a 4 and a 2 and a constant. The technique is not new. Yeah. But it's got to be even half constant to work. So I'm in degrees, the exponents. Yes, yes. All right, slash it. Yes. What's the GCF of the first two? 2x squared. What's left? The middle sign stays. What can I take out of the last two? 1. What's left? The middle sign stays. If the middle sign is negative, it changes the last sign. But otherwise, if it's plus, it keeps whatever sign was there. So what's the GCF now that comes out? Or what's the factor that I take out and put in front? X squared. I always do this one first, but the order does not matter. And what's left is the 2x squared plus 1. Now, here's part of the new part. We're going to do what's called factoring completely. And factoring completely means you look at every parenthesis and factor again if you can. Okay, so in other words, I might do this and I might get here and I might be able to factor that one again. I can't here. I can't here. But if I had worked my way down and gotten something like x squared minus 4 times x squared plus 7, well then this parenthesis I could break down again because I know that that's what? Difference of squares. Do y'all remember when we talked about difference of squares? No, because 2 is not a perfect square. They'd both have to be perfect squares. Yeah. Okay, yeah. Tell me when Grayson. Work with what? Moment of poor decision making. I don't know. I'm just thinking. All right. Grayson. Some of you are asking about the breaking up in the parentheses. All right, yes, we'll do some more examples. Let me show you. Let's flip over on your paper to look at 14. Let's do 14 together. If I am factoring this, actually, let's do 20. 20 is a little harder. All right, so my first thought is, can I take anything out? Nope, can't take anything out, right? So my next thought is, it's got 3 terms. Is it quadratic form? Yes, it is. What am I looking for? Walk me through it again. Even degree, half of the degree, constant, right? That checks off. So now, is there anything that multiplies to negative 24, c to the 4th? Where did I get that? First and the last multiplied together. What multiplies? Oh. It's like the port's loose or something. What multiplies to negative 24c to the 4th but adds to 10c squared? 6 and 4, right? Negative, nope, 12 and negative 2. But they have to have a c squared on them, yes? Because they have to add to what's in the middle, but they have to multiply to a power of 4. Does that make sense to everybody? So I've got 8c to the 4th, and now I'm rewriting 10c squared. I'm going to do the negative first. Negative 2c squared plus 12c squared minus 3. It doesn't. I just always like the negative to come first. It makes it easier when you factor. All right, so if I slash it, what can I take out of the first 2? No. 2c squared, which leaves you with 4c squared minus 1. Do whichever one you'd like first. I prefer to put the negative first because I don't want to have to change that last sign. But if you did, it's fine. What can you take out of the last 2? 3. What's left? What does that look like factored? 4c squared minus 1, 2c squared plus 3. Am I done? No. What do you see? I've got a difference of two squares. These are both, this is a perfect square and this is a perfect square, yes? As long as they are separated by a minus sign. Do y'all remember this pattern? If it's something times itself twice and there's a minus in the middle, this does not work if it's plus, only when it's minus. Then to factor it, I did the square root of each one with a plus and one with a minus. Remember when we did quadratics and we talked about that? So what do? Not for 2c, that's right. So the square root, what times itself twice gives you 4c squared? 2c. What times itself twice gives you 1? So I do 1 minus, 1 plus, and then the 2c squared plus 3 stays. Now am I done? Yes, because I know I'm done because I look at each parenthesis here and none of them can be broke down any further. Does that make sense? All right, huh? No, because we got a couple more patterns. Now, that's calculus's test correction. They're big mad about it. Sometimes we do. All right. Now, let's talk about two more patterns that come up with polynomials. It's the square root. I use this pattern. Yes. It's not a number. Factor it. Factor it completely. I am. About both of those terms. Not 8, you got to do square root, not half it. So 4x squared minus 9, 4x squared plus 9, right? That's what difference of two squares says. If you've got two things that are both perfect squares separated by a minus sign, I can do the square root of each one with a plus and one with a minus. With quadratics. Unit 1. Because now in unit 1 it didn't go higher than a degree of 2. Now this is a degree of 4. Okay, so what now? Am I done? No, we get through like 8. What now? Huh? It would. It absolutely would. This one will break down again. This one will not. Why will the first one but not the second one? Okay, this is still the perfect square, so I got 2x minus 3, 2x plus 3, but this one will not because it's a plus sign, so now it's factored completely. Only with the negative, and I'm fixing to throw a wrench in that too, so just hang tight. Tomorrow, today, next week.
Okay, after this semester.
We probably were supposed to have one today because I've been slack. Y'all never had a polynomial analysis quiz. Okay, we do too much fucking. Yes.
Like the day before, fall break, like all morning, like
All right. Ways to factor polynomials. Polynomials means it could be a quadratic. It might even be a cubic or a quartic or a quintic. I'm going to show you the patterns here, okay? So, first of all, I want to always check for GCF. And then the next thing I want to do is I want to check for a special pattern. Now, you already know two special patterns. Tell me one of them. Perfect square trinomial. All right, so perfect square trinomial, that's when the first one is a perfect square, the last one's a perfect square, and either I add or subtract double the product of the square roots of the ends, which is a mouthful, but that's where square dance is, remember? This only works for us right now when it's a quadratic. Okay, so I'm going to put a little note here. This is a quadratic method.
When did we ever do 8 minus 8 squared? Just to see, hold on.
What's ridiculous?
You think you know where you think we're as smart as you know. You think we're as smart as Matthew is not.
Remember? Okay, come over here to the side. Perfect square trinomial. You don't have to write this if you remember perfect square trinomial. This is just... The ends are perfect squares. The second sign is a plus. What times itself twice gives you the first term? 1x. What times itself twice gives you 5. If you multiply 5 and x together, what do you get? Double it. Remember, square, square, multiply, and double. 10x. That's what's in the middle. So to factor this, that's how it factors. It's always the first sign. What we did was checking the okay. Second sign is a plus. Y'all remember when we completed the square? Okay. Listen. The end terms are both perfect squares. Yes? The second sign is a plus, right, Will? What did I say? The ends are perfect squares. The second sign is a plus. The middle term is the product of the square roots of the ends doubled. Meaning if I do the square, square, multiply and double, I get what's in the middle. Those are all my checks to see if it's a perfect square trinomial. Stop it, boy. If that's true, then this is how it factors. Square roots. Okay, I'm going to go on for those of you who want to be with me. Difference of two squares. Again, we learned this first in the quadratics unit. The thing about math is, as you all know, it builds on itself. Nothing ever goes away. So what we learn in Unit 1, we do continue to use as we go. So, oh my gosh. Nothing. So to factor the difference of two squares, I do the square root of the first and the square root of the second, one with a plus and one with a minus. Now this does not have to just be quadratic anymore because it could be to the power of 4, to the power of 6, to the power of 10, any even power I could find the square root of. Okay. Now, I'm so glad you asked because Number 3 and 4 are the sum and difference of cubes. Now, what's a cube when it... Oh, it might be different than your sheet. Yeah. All right. How?
That was good. That was good. I was really saying work at
All right. Sum and difference of cubes. All right. Cubes means power of 3 or something multiplied by itself 3 times. Grayson, give me an example of a perfect cube. Numeric. Give me a specific example.
369.
Which is 27 is a perfect cube.
Wait, this is for instance an odd.
Yes. Give me another perfect cube.
10 to the 3 is 125. Or no,
8. Thank you, Finley. Give me another perfect cube. 64. Give me another perfect cube.
125.
125. Give me another perfect cube.
216.
216. Give me another.
360.
Why won't that go away? 216. 343. At least be able to recognize up through that many.
I still got a square.
That will help you. Let me help you during enrichment with the squares. I'll help you whenever we finish. Right now, let me get through the new stuff. All right. Be able to recognize all of these as perfect cubes, okay? Now, Grayson, what number times itself 3 times gives me 216? 6. What number times itself 3 times gives me 8? 2. What number times itself 3 times gives me 343? 7. What number times itself 3 times gives me 64? 4. Okay. How many what? I don't. All right, here we go.
Above 7. It's like that's 2, 3, 4, 5, 6, 7.
Yeah. This goes through 7. All right, I'm going to give you both of these at the same time because they follow the same way, okay? I'm going to show you how to set them up. This is just a memorization thing. That's the best way I know to tell you. So I'm going to show you in a general form like this, and then we'll do a couple examples with it, okay? Here's what we do. If you see, notice this is plus or minus. When we're in squares, it can only be minus. But when we're talking about cubes, we can do sum or difference, okay? I'm fixing to show you. Okay. Stay with me on this, okay? When you factor this, it does not look like it normally does. When you factor this, it gives you a binomial times a trinomial, which means it's a little parenthesis times a big parenthesis. Little parenthesis times a big parenthesis, okay? It's going to be a binomial times a trinomial. The first thing I do is fill in the sign, okay? The signs on these are going to be the same, change, and the last sign is always a plus. So here this would be plus, minus plus. But down here, I don't, but just wait, stay with me. I'm doing a general one first. Down here, same would be, right, okay? If I'm factoring a sum or difference of cubes, I always do little parentheses, big parentheses, same, 1,000 times, and I hope it will stick with you and you'll remember. Little princey, big princey, same change plus. Little princey, big princey, same change plus. Okay? We'll say it over and over and over. All right. Now I fill in. Filling in's a lot easier than remembering this part. So I do what times itself 3 times gives me this value. That's just A. This one's just going to be B. Okay? Same down here, A and B. Should do this so you can compare. All right. You take the first one and you square it and put it in the first place. You square the last one and put it in the last place. And the middle of them, you just smush them together. Nope, just AB. Smush the first. You always use the little parentheses to write the big. Just AB. Just AB. So A squared, AB, B squared. Let me show you an example. We'll do an easy example and then a little bit harder one.
Well, it's 7. That's the line was 7.
Okay, but what's the pattern? Name it.
Oh, okay, it's plus minus plus sum.
Okay, sum of 2 cubes, right? I know it's cubes because when I see this exponent, I'm going, okay, I know that's a cube, so are the numbers themselves perfect cubes? Are both of those numbers from my list of perfect cubes? Yes. So I know because it's a sum of two cubes, I'm going to go ahead and set up my parentheses. I don't even have to know if it's sum or difference. I just have to recognize them both being cubes. Little parenthesis, big parenthesis, same change plus. Little parenthesis, big parenthesis, same change plus. Little parenthesis, big parenthesis, same change plus. Big parenthesis, same change plus. Same change plus. All right.
I really don't like understanding sum anymore because like, when am I going to use any of that?
All right. What times itself 3 times? What can you multiply together 3 times and get 8x cubed? 2x. Everybody understand where that number's coming from? What can you multiply by itself 3 times and get 343? 7. Now you Now take these values and use them to write the second parenthesis. Now 4x squared. You got to square both of them. 4x squared. What goes in the middle? Okay. You square this one. Okay, well, what's the last one? You can. 14x. Thank you, Finley. It's just been multiplied together. You put them together in the middle.
Oh, it's the first parentheses multiplied together? Would it not be
Yes,
2x?
once you get the first parentheses, that's all you're using to write the other.
What is it, 2x times 7?
Yep. Multiply these two together to give you that one. Just square the 7. What's 7 squared? It's really not. It's not. Look at number 8 on your homework. Look at number 8 on your homework. Wait. What's your first step before you factor? GCF. Always GCF. That is always our first step. Does this have a GCF? 2, I can at least take a 2 out. Minimum, I can take a 2 out, right? If you take a 2 out, what's left? 27x cubed plus. That's where y'all tell me what's left on the other one. 125 y cubed. Look at the parentheses. Because factoring completely is constantly looking at the parentheses that you have to see if I can factor them any further. All right, so what do you see? What do you recognize? Perfect cubes. They're both perfect cubes. Does everybody see that? What times itself 3 times gives me 27? What times itself 3 times gives me 125? So I can go ahead and set up, I got a sum of 2 cubes, right? The 2 is going to keep following my problem down. But I need to set up my parentheses. What do I do? Little parentheses, big parentheses, same, change, plus.
Little parentheses, big parentheses, same, plus.
Little parentheses, big parentheses, same, change, plus.
Again, whole class. Ready? Little
Parentheses, big parentheses, change, plus.
Again.
Little parentheses, big parentheses,
Same, plus.
Am I dreaming right now? Please tell me I'm dreaming.
Why? What do you think you're dreaming? Because this is so much fun. It's a dream come true.
Not everybody participates.
Okay. Sit down. All right. Will. All right. Shh. Finley, look at my parentheses. What goes in my first spot here?
Same. 3x.
3x. What's my next spot? 5y. Now I don't even have to look at any of this above that line anymore. I just use this little parenthesis to fill in my second parenthesis. 9x squared. Square the first one. 9x squared. There you go. 15xy. How about the last spot? 25y squared.
Are we done?
Little parentheses, big parentheses.
13 plus.
All right.
Whole class. Ready?
That is a great question because it very much looks like it could be. So Matthew's question was, since we're factoring completely, is that a perfect square trinomial in that last parenthesis? Right? We're talking about this one right here. What are my criteria for perfect square trinomials? Last one has to be a plus. Done. The ends have to be perfect squares. Done. Question is, does it square dance? What's the square root of the first one? 2x. What's the square root of the last one? If you multiply them together and double them, do you get what's in the middle?
No.
It's never doubled, okay? This on a perfect square trinomial, this on a difference or sum of 2 cubes will never be a perfect square trinomial. It's very, very close, but it will never double in the middle. So it'll never be a perfect square trinomial. Okay?
Why would you?
Some of them might though. But if you do a cube, it's never going to square dance in the end. It won't. Oh, okay. Well,
Can you eliminate some of the
all right, listen. Let me walk you through a couple of things on here, okay?
Can you eliminate some?
You have to. No, these are okay. All right. If there are only 2 terms, we are checking for. Well, what are we checking for? If there's 2 terms, what?
GCF.
A difference of 2 squares, or a sum or difference of cubes. Okay? That's the now GCF is going to be the first thing you do with every single one of them, okay? But what I'm saying is if you see 2 cubes, so 5, 6, 7, 8, 9, 10, 11, 12. Those are all, once I take out a GCF, I'm looking at them, they've got to be one of those 2 if I factor them any further, okay? Because there's only 2 terms. Now, if there's 3 terms, okay, it could be a perfect square trinomial. It could be a quadratic factor group by grouping. or it could be a quadratic form. That's what you have to determine. All of these are grouping. That's where we multiply the last and the first together. We find the two things.
Are 10 and 11 three terms? Are 10 and 11 three terms?
No, 10, 11 are two terms.
So 3 times is
13, 14, 15, 16, 17, 18, 19, 20 are all three terms. Now, when we get to four terms, and we haven't talked about a lot of these, I'll do one of them with you. 21 through 24. No. Four terms, which is numbers 21 through 24. They're actually easier. You're going to slash them as is. The way they sit in the problem, they've already rewritten that middle term for you. And you're going to slash them that way. So let's do one. Pick one. One of the, yes.
23.
Slash it as is. I'm just going to show you. It's already been rewritten. Golly. I'm fixing to show you. Let's do 24. There's four terms whenever I start, right? So I'm going to definitely try just to slash it. First and stop it. What's the GCF of the first two? What can I take out of the first two? N bigger. 3n squared. What's left? 5n minus 2. The middle sign stays. What can I take out of the last two? What's left? Remember that last sign changes if the middle sign is minus. Okay? Now I know it worked because my factors in parentheses match, yes? So I've got 5n minus 2. I'm done with that. I'm done with that. Times 3n squared minus 5. See, it's an easier factor because the first step's done for you. That's it.